Number 8. Ooh, this one's interesting. It almost looks like there's nothing we can do. Almost. Is it currently the difference of anything?
No.
No.
Not yet.
Not yet. So 625 is a perfect square. What is it the square of? 25. So this is 25 squared. And then this is almost a perfect square, but not yet. Okay? Remember, square numbers are not negative. All squares are non-negative. That's a property that we have. So what can I do with this expression so that I have both numbers are square numbers and it's a difference? So if we multiply the whole expression by -1, we've basically changed it because it's just an expression, not an equation. So in order to be able to multiply by a number, we have to have two sides of an equation so that we can do it to both sides to keep it equivalent. We don't have that here. What are we doing? Factoring. So what are we going to do? Instead of multiplying, we're going to factor out that negative. So when I factor out that negative, what remains?
16 and to the fourth minus 625.
And now I have a difference of squares. Had I been here yesterday, I would have talked about the fact that if I have an exponent that is a multiple of 3, it is a perfect cube. What multiple of 3 is 9? The third. So x to the 9th is the same thing as x cubed. If I have x to the 15th, is 15 a multiple of 3?
Yeah.
What multiple of 3 is 15? The 5th. So I have x to the 5th raised to the 3rd power. So if it was a multiple of 3, it was a cube. Is this a multiple of 2?
Yes.
Therefore, it is a square. It's a multiple of 2, so it's a square. All right, since we have that established, I'm going to keep my negative, and I'm going to rewrite this as a square. So 16n to the 4th is the same as the square of what?
4n squared.
4n squared. And we said earlier 625 is the same as the square of, whoops, wanted a different color. So 625 is the same as the square of 25. So we have a difference of squares. So we can factor that using the formula. So my -16 n to the 4th plus 625 is going to break down into negative. We're going to have a difference of squares here. So what's going to go in this first binomial? Or n squared. Sure, minus what?
25.
That works. And then what about over here?
4n squared plus 25.
Are we done? Is it factored completely? Why not?
By 4.
What do we have here?
Perfect square.
What special case does that make it? It's not a perfect square. Difference of squares. So we're going to do the same thing we just did, and we're going to take this factor and break it down into its binomial factors because this is a difference of squares again. So I have negative Then I'm going to break that down into its two factors. And I'm going to still have the 4n squared plus 25 over here. So what is 4n squared minus 25 going to factor into? I heard plus and minus. Does it matter which one I use first? Okay, I chose plus first, so what does that mean for the second one?
2n minus 6.
And we can't forget about that negative we factored out to begin with.